Hey guys, today's notes are going to be about deductive reasoning. This is our last notes for this unit before we start reviewing for the test. So our learning target is I will be able to use deductive reasoning to make valid conclusions. So this is all about reasoning through given statements and finding the conclusion. So first, we have the law of detachment, which says that given if P then Q and just P, then you can conclude Q. So basically you're given a statement if P then Q, and then they just give you P, so the conclusion is Q. So the key word here to remember is detach, hence the name law of detachment. So our example here, if someone is tired, then they will sleep in. Brian is tired. So this is our dangling P right here, and this was given the if P then Q. So if Brian is tired, then Brian will sleep in. This may seem a little silly and straightforward, but it is just a way to draw some conclusions. So again, that symbolic form here is given P and Q. If P, then Q. Alright, next up we have the transitive law. So given if P, then Q, and if Q, then R, you can conclude if P, then R. Excuse me. So what I think of for the transitive law is kind of like a chain, like links in a chain. If P, then Q, Q connects to this next chain, Q, then R. So the end of it is the beginning to the end of the chain. If P, then R. So our example, if you are hungry, then you will cook some food. If you cook some food, then you make pasta. So I'm given if P, then Q, and then my Q connected to a new statement. So I need a new letter to represent that. So I have R. So once I've color-coded it like this, I like to go through and cross out the Q's that connect, because those two connect, so now I just need to connect the beginning and the end. So my conclusion is, if you are hungry, then you make pasta. So again, if you underline it by the different colors of the statements and cross out the ones that connect in the middle, then your answer is just the beginning part and the end. And your symbolic form again is down here, given if P, then Q, and if Q, then R. You end up with if P, then R. Alright, that's all we're going to do on the front. So go ahead and flip this over, and we've got some properties to review on the back. So first up, we have the distributive property. These are going to look familiar to you guys, but we want to make sure that you understand them. So if A, parentheses B plus C, then A, parentheses B plus C equals AB plus AC. I'm going to draw my little arrows here to remind me that I distribute out that multiplication. You'll notice I'm writing all these definitions with our if-then, so they're all conditional statements. So this is just another reason why we learned all of that logic that seemed a little out of place in geometry. So just a quick example for you guys. 3 parentheses x plus 4. Remember, you just distribute that 3 across. So we end up with 3 times x plus 3 times 4, which gives us 3x plus 12. Alright, moving right along to our substitution property. If A equals B, then A may be replaced by B. So this is all about replacement. So an example, if A equals 3 and 4A plus 1, then 4A plus 1 equals, I can substitute in 3 for A because A equals 3. 4 times 3 plus 1, and I can simplify that to 12 plus 1, which simplifies to 13. Next up we have our transitive property. So this is very similar to the transitive law, but this is a property that we will use as parts of proofs rather than how the law is to just find conclusions of statements. So if A equals B and B equals C, then A equals C. So an example for you, if X equals Y and Y equals 5, then X equals, what do you think? If I've got X equals Y and Y equals 5, X equals 5. Alright, 2 more to go. Our reflexive property here. This says that for any real number A, so you guys learned about those real numbers in Algebra 1 last year, then A equals A. So any number A,
Sharon Ponton, please come to the main office. Sharon Ponton, please come to the main office.
so any real number A is just equal to itself. So like 3 equals 3, -7 equals -7, or if I wanted to call two numbers A, B, so those are two random numbers being multiplied, they're equal to the exact same thing, A, B. So any sort of number is equal to the exact same thing as itself. So for reflexive, I remember a mirror, because when you look in the mirror you see your reflection. So reflection, reflexive tells you it's the exact same thing on each side of the equal sign. That is very important because our next and last property is called the symmetric property. And this says if A equals B, then B equals A. A lot of people will confuse these two properties. Reflexive is very straightforward. It just has to be the exact same thing on each side, whereas symmetric would look like this. X equals 4 and 4 equals X. So each side of the equal sign has something different, but since they're equal to each other, we can write it in whichever order we want. So a more complicated example could look like this. 3 times 4 equals 12. And 12 equals 3 times 4. Another example, AB equals BA. This is a really good example to remember for symmetric, because it looks like our example up here for reflexive, but since the order has been changed, this is symmetric and this is reflexive. Alright guys, that's it for all of our properties and those last two laws. So I will see you in class tomorrow.